If we can able to program it, in future also we can able to use the same system for any camera. So the programmability of the hardware will be the better solution when we go for a real-time application where the technology we keep on changing. So the sensors we are going to use, that means the camera sensors or the VGA for the display. So this is the OV76 sensor which we are going to use for the experiments. That means this is a basic Arduino sensor only, but it will be suitable for the FPGA also. It has only a VGA resolution, so that's what the output module we fixed it for the VGA. So if you want to fix anything, we need to understand what it is. It means we need to analyze what is the VGA parameters. So if you want to display it or if you want to store the video in terms of VGA format, we need to understand what kind of format we have to store the video. So what are the pixels are there? This pixel, how I can able to convert into some other format. So if I want to understand this camera sensor's property, I have to understand. So this camera sensor purely giving a VGA resolution and VGA format. So first we need to understand the VGA. The next is the algorithm. So the proposed algorithm actually needs a partial parallel. We are not going to process a complete serial or complete parallel. The reason this sensor has a IO which is as a input output pins. So whenever it captures any video or image, it will send the pixels through the GPIOs. So it has a only 8-pin GPIO for the data port which is used for the pixels. So but the problem, this 8 pins will not give the complete pixel. So if you need to read the complete pixel, at least we need to spend minimum of 2 clock cycles. 2 clock cycles. It means 2 states. So first state it will give half of the pixels. Second state it will give another half of the pixel. So once you combine this 16 bits together, it will give the single pixel information. So if you want to process a system or if you want to process based on this camera, your algorithm should fix for the partial parallel. It will not go for the serial, it will not go for the parallel. The reason based on the input. So even though if I create a system for the parallel system, completely parallel, I need to store all the inputs in a buffer, then I have to process the input. But still, the input, if I want to store it for the 5 pixel, I need to spend for 10 clock cycle. So after 10 clock cycle, even the parallel system, if it try to process the 10 pixels, again it need to process it some other number of clock cycle. So again it will go for the serial or parallel kind of. So it will be a little tedious one to select what kind of algorithm you have to use. So the next one is a implementation. Here it's a combination of both. Some portion of managed with the mathematical functionality, some portion of the hardware are managed with the logical functionality. So as I said before, the quality, it should satisfy the performance and need. What is the need in the sense? Camera we are processing, we are taking a picture or video, it has to capture the video or image, it has to store it in the device or even the display, whatever it's showing. It has to encode the data and then the resulted video alone, it has to come with the output port. From the camera itself, whatever the data we are getting, that will be the encoded video or the encoded image, which has the sensitive information inside it. So once we capture this sensitive, that means the video or image with the sensitive information, later wherever you store, it will ask the information inside it. So someone else trying to hack or trying to change the information inside it, they can't change the information. So once you retrieve the data back, reverse watermarking, so once you did it, you can able to retrieve your own authenticated data. Somebody get morphing or somebody tamper the video, not retrieve the proper authenticated information. So you can able to easily say this is a tampered video or else this is a morphed video or morphed image. So what we have as an input. So the input is from the camera module as a pixels. So that's what we need to analyze information. What is the number of bits for this color? So first we need to analyze what are these things. So the color, we know the different called in the digital. So sometimes the analog, whatever we say, we can easily say it's a red color or green color or something else. But for a system, if it is a different level, that means different types of color or different colors, it need to understand what color it's going to process. So for each color, how many different number of color signals, something like level is mentioned in terms of color. So this color information, if you want to process in a system domain, we'll say in terms of pixel. This pixel is nothing but the smallest possible area. Something